Hello and welcome to VitoshAcademy. Today we'll be talking about correlation and statistics. So in a few minutes you'll see where Pearson correlation shines, where Spearman is safer, how outliers can fool you, and how to scan many features fast with a heat map. Okay, so these are our imports here, 5 of them. And let's put a random seed so everything is replicable. And then we'll simply put 2 or 3 functions that would be used further in the code. So correlation values is the first one. And what it returns is Pearson R, Pearson P. Then we have Spearman R and Spearman P. Pretty much once we give the X and the Y, and FMTR pretty much would return something like 7 divided by 3. Yes, up to 3 digits after the decimal. And if we use FMTP, it would be 5 digits. This is something that we are using for lambdas, and just to make sure that it works. Okay, so let's just talk about really quickly about R and P. So R is the correlation coefficient that goes from -1 to +1 scale. Magnitude is strength, sign is the direction. So -1 means they are not exactly correlated in the same direction. On the contrary, on the different directions. +1, it means they are correlated on the same direction. P is simply a check whether there is an association between the two values that we are checking. How often would we see an R at least this extreme just by random chance? So small p flags statistical signals, not importance, and just something that should be always mentioned when we talk about correlations is that correlation doesn't prove causation. So that's a must-have. And let's start with a really quick, simple example, which is going to be kind of a warm-up. So you are aware of cars. The older the car is, the cheaper. The more, if it is brand new, it is expensive. So pretty much you are quite familiar that the car price drops with age. And here we already have 8 simple 1, 2, 3, 4, 5, 6, pretty much 6 years, and the price is something like this. It can be in US dollars, in euro, in whatever you feel like. Okay, so now let's generate the values. And the values are here. And now let's do the plot and try to see what we can do. Then we're going to print these values that I have just generated for you. Okay, now what do we have? Ultra simple price versus age of 6 cars. And we see that the highlight here covers around 95% of the confidence pretty much interval. If we want to have it like 100, it would be a bit more. Just checking. Yeah, you see. But 90, and if you want to make it like 1, it will be just a line. So 95 is good. Just to have us an idea. And what do we see? We see Pearson giving some numbers and Spearman giving some other numbers. Okay, what does it mean? Let's talk now about Pearson and Spearman. Talking about correlation, these are like the 2 main schools, so to say, or 2 main methods to go to correlation. So Pearson, this one here, it measures linear association and uses distances, so it is sensitive to outliers and straight line patterns. Pretty much when it is straight line, it is good. About Spearman, it's a bit different. It measures monotonic association using ranks. It sees consistent up or down order even when curved and is more robust to outliers. So if we have something like outlier or not exactly a line, then we should go with Spearman, otherwise with Pearson. And you can see here that we just say stats.pearson r and then stats.spearman r. These are like the way to make correlation. Let's see if we put stats.something else. Tab. There are a lot of other ways, like Bernoulli. Yeah, this is not related exactly to correlation. So let's continue here. What do we see on the graph so far? We see 2 points. Both correlations are strongly negative because older for cars almost always means cheaper. This is like how our data looks like. A 1-year car is 40,000 and a 6-year-old is 22. So yes, so strongly negative correlations, minus 998 and minus 1, which is good. And the line here, it's actually a linear regression fit estimated by ordinary least squares. As I mentioned, the light band is 95%, which is, so to say, confidence band, confidence interval here, CI. And it is pretty much around the mean of the fitted line. If we want to remove this one, we can simply write here none. And it's not here, but 95 was pretty good to have. Okay, so let's go deeper into Pearson and Spearman. I have prepared pretty much the same example, just a slightly larger data set. And it is still really near linear. You can see like a 1-year-old car is 38,000 plus some random noise, so to say here, 0.2 minus 0.3. And we calculate pretty much the same thing as here. Why Pearson is a good idea to check it. Pretty much there is a straight line, so Pearson should be near 0 minus 1. Spearman should be also somewhere there. So let's press Shift and Enter and just see. Yes, Pearson is minus 995, Spearman is minus 1. Both are okay. And they are quite good. Okay, the P is obviously 0, 0, 0. If we improve it somewhere here, let's say to 15 numbers, one of the P's is going to be improved. So it shouldn't be a 0, but it is really good. Okay, this one, even with 15, it is 0. So bigger ones should be present. I'll just keep it into 5 just to show you how it works. Okay, now let's do something with Spearman. Spearman, we're gonna test price of the car versus horsepowers. And the idea is that price rises with horsepowers, but with diminishing returns. So order increases and the shape is curved. So there we'll see with the prepared example that Pearson and Spearman, in that example, they are different. Copying the code and pasting it here. And running it. Okay, so price versus horsepower, this is how it looks. Just on a scatter. Yeah. Thinking, should we put the line? No, it's visible where the line should be, but it is visible that it is a scatter. And let's see, Spearman gives 1, Pearson gives 98.985. Why Spearman is way better here? It stays high because higher horsepower ranks match higher price ranks pretty much. And Pearson is smaller, because a straight line underfits the curve, so to say. The idea here is to show that Spearman really shines here when we have some kind of a curve and it is not exactly linear. Okay, let's make it a bit more interesting. Let's imagine that we have a old exotic car that doesn't exactly put itself on the fit. It can be like a 10-year-old or 8-year-old Ferrari. Yeah, let's take a look how it will look like. It will look something like this. So if we want to see the price, so we'll see here that we have a 120,000, which is way different than the other cars, and the age is 10 years. So let's see how this one is going to disrupt our data. Okay, so getting the prepared code and pasting it. And let's see, what do we have? Well, we have two pictures. Original price versus age. This is what we had also here. And with the exotic car, everything looks a bit different. Yes, pretty much Pearson moves a lot. This is the original Pearson. And this is with the Pearson with the outlier, the exotic car. It really moves a lot. I mean, from this into that, it is moving. So it's because the regression line is pulled towards the outlier, as you see, instead of here, it goes there. And Spearman moves less because ranks change little. So Spearman goes from -1 to -0.72, which is rather okay. I mean, it also took a look at the outlier. And what we can use as a take-home message is always visualize and report both when curves or outliers are plausible. Pretty much try to visualize to see what's going on. And yeah, having both Spearman and Pearson is a good way. Okay, so we're going to the last example of the video. We're going to talk about heatmap, and we're going to compute Spearman correlation across tiny car table and annotate every cell there. So let's take a look how it looks like. Ta-da! So we have the cars, we have the prices, we have the age of the years, we have the mileage in kilometers, the horsepowers, and information whether it's a premium car or not. Pretty much you can see that this one is premium, the last three are premium, this one is not premium, so there could be something. Spearman correlation is generating, and let's press Shift and Enter and to see how the whole thing looks. Okay. So what I don't like here is the fact that we don't have the correlation indices here for each one of the values. What we can do is we can improve it. I have prepared just a tiny bit more. I should replace something. Let's see. This one should be replaced, and probably no, this one stays. Yes, this happens sometimes with the SNS. Now the heat map looks way better. What is interesting is, for example, price K to price K is always 1 because it's correlated, it's pretty much the same. Age years to age years is 1. Like this diagonal here, if this was a matrix, this would have been the main diagonal. If this was like a chessboard, this would have been the white diagonal. But in our case, it is the diagonal of the ones. So this one is always 1. And let's see how to read it. Pretty much strong negative price age and price mileage reflects depreciation of air. So where? So price, we have these two strong negative years and mileage, yes. makes sense. Horsepowers towards price is almost 1. Yes, it's a positive one. And premium to price, well, we can say has some kind of effect. Okay, so we can see that we are using top 3 absolute correlations with price K on Spearman. So pretty much age years, mileage, and horsepowers. We're talking about the first row here. Okay, so Spearman is a good overview when mixes or trims exist, so to say. Okay, so far so good. Let's make a quick recap of the video and hope that we have learned something. So shift and enter here, and we have the R, and we have to talk about the R. So R is a standardized effect size from -1 to +1, and P pretty much is showing how rare it would be that your R would be there if there was no association. I don't know if you know the story about how the P existed, you can write it down, otherwise I can give you a hint. It is about a woman who was claiming she was able to guess whether you put first milk or first tea in a teacup, and someone was asking, okay, how many tests should we do in order to make sure that she's not just guessing wildly, but she knows how to do it. And the answer was around 10, and indeed she was able to understand whether it was first tea or first milk put in the cup. Okay, so then we made some linear depreciation, which looks good. Both Pearson and Spearman performed quite well on this one. Yes. Then we made price versus horsepower with diminishing return. Okay, yeah, I'll say Spearman shines here easily. Next, we put our exotic car, 10-year-old, 120,000, so to say. We created an outlier, and we asked both Pearson and Spearman to give us like their result. So Pearson failed a bit, not seeing anything interesting, while Spearman saw something, and it looks okay. At the end, we made the correlation heat map, and this is how it looks. Top 3 absolute correlations with price, as per Spearman, are age, so to say how old the car is, the mileage, and the horsepowers. So thank you for watching VitoshAcademy, and I hope you enjoyed what you saw so far. If you have any questions, drop a comment. I usually read them and I enjoy them. Have a great rest of the day. Goodbye.